Mercury is a fascinating planet. It's not just its proximity to the Sun that makes it interesting, but also its unique characteristics and extreme conditions. It's the smallest planet in our solar system, even smaller than some of the moons orbiting other planets. Despite its size, Mercury has a significant impact on our understanding of planetary science. And it's also the closest to the Sun. This proximity means it experiences some of the most extreme temperature variations in the solar system. This small rocky planet is a world of extremes. Its surface is covered with craters, much like our moon, and it has virtually no atmosphere to protect it from the Sun's intense radiation. It's incredibly hot during the day, with temperatures soaring up to 800 degrees Fahrenheit, and unbelievably cold at night, dropping to minus 290 degrees Fahrenheit. These drastic changes make it a planet of contrasts. Mercury is a planet full of surprises. For instance, it has a magnetic field, which is unusual for a planet of its size. This magnetic field is about 1% as strong as Earth's, but still significant. One of the most interesting things about Mercury is its density. Despite being the smallest planet, it is incredibly dense. Mercury is the second densest planet in our solar system after Earth. This high density suggests that it has a large metallic core. This means that it's packed with a lot of heavy stuff. Scientists believe that this core is primarily composed of iron, which accounts for about 85% of the planet's radius. Scientists believe that Mercury has a very large iron core. This core is thought to be partially molten, which could explain the planet's magnetic field. This core makes up a large part of the planet's interior. Understanding the composition and behavior of Mercury's core helps scientists learn more about the formation and evolution of rocky planets. Mercury is a planet that we're still learning about. Missions like NASA's MESSENGER and the European Space Agency's Bepi Colombo are providing valuable data. It's a challenging planet to study because it's so close to the Sun. The intense heat and solar radiation make it difficult for spacecraft to operate, but scientists are making new discoveries all the time. For example, they've found evidence of water ice in permanently shadowed craters at the poles, which is surprising given the planet's proximity to the Sun. As we learn more about Mercury, we gain a better understanding of our solar system as a whole. Each discovery about this iron planet helps us piece together the history and dynamics of the planets orbiting our Sun. Imagine standing on the surface of Mercury. The Sun dominates the sky, appearing several times larger than it does from Earth. As you feel the ground beneath your feet, you realize it's baking hot. The temperature here can reach a staggering 800 degrees Fahrenheit. That's hot enough to melt lead. This intense heat is due to Mercury's close proximity to the Sun. In fact, it's the closest planet to our star. Because of this, Mercury receives much more solar radiation than Earth does. This makes the surface temperature incredibly hot, especially during the day. The heat on Mercury is nothing short of extreme. It's a harsh and unforgiving environment. But even on this scorching planet, there's more than meets the eye. Stay tuned as we delve deeper into the reasons behind Mercury's insane temperature swings. Mercury's extreme heat is a direct result of its proximity to the Sun. Imagine our solar system as a giant campfire. The Sun is the roaring fire at the center, and the planets are like campers sitting around it. Mercury is the camper who decided to set up camp right next to the flames. Because Mercury is so close to the Sun, it receives far more solar radiation than Earth. This means that the surface of Mercury is constantly bombarded with intense energy from the Sun, leading to its incredibly high temperatures. This intense heat is one of the defining characteristics of Mercury. It shapes the planet's surface and makes it a challenging environment to study. But despite the heat, Mercury is a fascinating planet with many secrets to uncover. Unlike Earth, Mercury has virtually no atmosphere to speak of. Imagine our atmosphere as a giant blanket that helps to trap heat from the Sun. Mercury, unfortunately, forgot its blanket at home. This lack of a substantial atmosphere is a key reason why Mercury experiences such drastic temperature swings. Without an atmosphere to trap heat, Mercury loses its heat to space very quickly. It's like taking a hot pie out of the oven and putting it directly into a freezer. The heat dissipates rapidly, leaving the pie cold. This lack of atmosphere makes Mercury's environment even more extreme. It's a stark reminder of the important role our atmosphere plays in regulating Earth's temperature and creating a habitable environment for life. Mercury has an incredibly slow rotation compared to Earth. It takes about 59 Earth days for Mercury to complete one full rotation on its axis. This means that a single day on Mercury lasts almost 2 Earth months. This slow rotation has a dramatic effect on Mercury's temperature variations. The side of Mercury facing the sun bakes in the intense heat for weeks on end. Meanwhile, the side facing away from the sun experiences a long, frigid night. This extreme difference between day and night temperatures is another reason why Mercury's temperature swings are so insane. Section 6. From fiery hot to freezing cold. As the sun sets on Mercury, the temperature plummets dramatically. Without an atmosphere to trap heat, the surface of Mercury rapidly cools down. Temperatures can drop to a staggering -290 degrees Fahrenheit or -180 degrees Celsius. That's even colder than the coldest temperatures ever recorded on Earth. This extreme swing between scorching hot days and freezing cold nights is one of the most remarkable features of Mercury. It's a testament to the planet's harsh and unforgiving environment. This drastic temperature variation makes Mercury a challenging planet to study, and even more difficult to imagine ever setting foot on. Section 7. Craters and ice. What a sight! Mercury's surface is heavily cratered, resembling our moon. The similarities are striking, with both celestial bodies bearing the scars of countless impacts. These craters tell a story of a tumultuous history, one that has shaped the very essence of Mercury's landscape. These craters are evidence of a violent past, with countless asteroids and comets colliding with the planet over billions of years. Each impact has left a distinct mark, creating a mosaic of craters that vary in size and depth. Some of these impacts were so powerful that they reshaped entire regions of the planet. These impacts have left their mark on Mercury, creating a landscape that is both rugged and fascinating. The terrain is a testament to the planet's resilience, with craters overlapping one another, forming a complex and intriguing surface. The ruggedness of Mercury's landscape offers a unique glimpse into the planet's geological history. Surprisingly, despite the intense heat on Mercury, scientists believe there may be water ice hidden in some of the planet's deepest craters. This discovery is particularly astonishing given Mercury's proximity to the sun, where temperatures can soar to extreme levels. The presence of water ice challenges our understanding of the planet's environment. These craters are located at the poles where sunlight never reaches. In these permanently shadowed regions, the temperatures remain incredibly cold, creating a haven for water ice to persist. The polar craters act as natural cold traps, preserving ice for potentially billions of years. The temperatures in these permanently shadowed regions remain incredibly cold, allowing ice to survive for billions of years. This phenomenon is a stark contrast to the scorching temperatures experienced on the rest of the planet's surface. The existence of such cold regions on Mercury adds another layer of complexity to our understanding of this enigmatic planet. The presence of water ice on Mercury is an intriguing discovery. It opens up new possibilities for scientific research and exploration. Understanding how water ice can exist in such an extreme environment could provide valuable insights into the conditions necessary for water to persist on other celestial bodies. It suggests that even in the most extreme environments, water, which is essential for life as we know it, can find a way to exist. This discovery fuels the imagination and drives the quest to explore other planets and moons in our solar system, searching for signs of water and, potentially, life. Section 8. Mercury versus Venus. A tale of two hot planets. While Mercury is the closest planet to the Sun, it's not actually the hottest planet in our solar system. Despite its proximity to the Sun, Mercury lacks a significant atmosphere to trap heat. This means that while it can get extremely hot during the day, reaching temperatures of up to 800 degrees Fahrenheit or 427 degrees Celsius, it also gets incredibly cold at night, dropping to -330 degrees Fahrenheit or -201 degrees Celsius. That title belongs to Venus, the second planet from the Sun. Venus, often called Earth's twin because of its similar size and composition, has a vastly different climate. Although Venus is farther away from the Sun than Mercury, it has a thick, dense atmosphere that traps heat incredibly effectively. This atmosphere is composed mainly of carbon dioxide with clouds of sulfuric acid, creating a runaway greenhouse effect. Venus's atmosphere acts like a giant greenhouse, trapping heat from the Sun and raising the planet's temperature to an astounding 867 degrees Fahrenheit or 464 degrees Celsius. This makes Venus the hottest planet in our solar system, even hotter than Mercury. This makes Venus even hotter than Mercury, despite being farther away from the Sun. The thick atmosphere of Venus ensures that the heat is not lost, maintaining consistently high temperatures across the planet. This comparison between Mercury and Venus highlights the importance of an atmosphere in shaping a planet's climate. While Mercury's thin atmosphere leads to drastic temperature fluctuations, Venus's dense atmosphere creates a stable, albeit extremely hot environment. While Mercury's lack of atmosphere leads to extreme temperature swings, Venus's thick atmosphere creates a runaway greenhouse effect, making it the hottest planet in our solar system. Understanding these differences helps scientists learn more about planetary climates and the potential for life on other planets. Section 9. One strange little planet. Mercury is a planet of extremes. From its scorching hot days to its freezing cold nights, from its lack of atmosphere to its possible reserves of water ice, Mercury is a planet full of surprises. Its unique characteristics and challenging environment make it a fascinating subject of study for scientists. As we continue to explore our solar system, Mercury reminds us that there is still so much more to discover. Each planet has its own story to tell, its own secrets to unveil, and as we delve deeper into these mysteries, we gain a greater understanding of the universe and our place within it.